This is a video about graphing using slope-intercept form, or actually using a table to get intercept, using a table when a graph is given to you in slope-intercept form. But the first thing I want to talk about is this. This is review back from when students were in 6th grade. And I'll give you an example first to kind of give you an idea. So an example would be Mike wants to go snowboarding. It costs $80 per day plus a flat equipment fee of $40. Write an equation that finds his TE total cost for D days. So what students had to do back in 6th grade is I had to be able to take this problem and write it into an equation. And what we saw as 6th graders is we saw mostly that these were multiplication and addition problems. And so there was always a key word that told me I was multiplying and a key word that told me I was adding. And what we did is we often put them together in a situation or an equation that looked like this. So for example, we have Mike. Well, I see per, so that told me that 80 is my multiplying number. And then I see flat fee of $40, so that was my adding. So my equation would be 80D plus 40 equals T, which is my total. And equations like that are going to be pretty familiar to students because we've seen these in 6th grade. Now we're entering the realm of we don't just write the equations. Now what we're going to do is we're going to be putting them on a graph. So there's a special name for equations that are in this form where you just have your two variables and one equals an equation with the other, an expression where the other one's included in it. And that's what we call slope-intercept form. So this is a special type of equation, and you can see it's very similar to the one that we were just working with. I have two things being multiplied, something being added. So slope-intercept form, the things that never change are y and x. And I'll underline those in red because those never change. The values that do change are m and b. Now m is the slope, and slope is what we see as change. Change in how is our values changing. So in the case of Mike, it was changing by $80 a day. Oh, and this is where I want to be. And b is the y-intercept, meaning that is essentially my starting point. So in the case of Mike, that was our flat fee. So we have to pay that right off the bat. Whether I do something or not, I got to pay that flat fee. Just like when we do shipping costs with mailing, sometimes you have to pay a constant shipping cost. So it's $9.99, whether it's 8 pounds or 85 pounds. It's $9.99. And so these are the two values that will always change. So here's an example. Here I have a graph, y equals 2x plus 1. When I have a table, I have my input, which in 6th grade we talked about as x, and then you have your output, which is y. And I always suggest these three values for x. If you can't pick, if they're not given to you, choose these four values because they're the easiest. And then what you have to do is you have to figure out what y is. Well, when x is 0, I would do 2 times 0 plus 1. Well, that's going to get me 0. 0 plus 1 is going to get me 1. Here, I have 2 times 1 plus 1. 2 times 1 is going to get me 2, plus 1 is going to get me 3. Next, when 2 is 2, I have 2 times 2 plus 1. That will get you 5. And then I have 2 times 3 plus 1. Now I'll get you 7. Now the part that students often kind of get oopsies on is how do I graph this? These are just coordinates. So to graph the point 0, 1, I go right 0 and then up 1, and there's my point. For 1, 3, I go right 1 and then up 1, 2, 3. For 2, 5, I go over 2 and up 1, 2, 3, 4, 5. For 3, 7, I go over 3 and then up 7. All I do is connect my points, and there you go. And that is how you graph a linear equation in slope-intercept form using a table.